I'm Anil Kumar. Welcome to my series on trigonometry. As per the demand of most of the students, here I'll discuss most of the formulas which you may use to solve any problem related with triangles in trigonometry. So we'll begin with very basic things, that is, what is sine, cos and tan. So let us say we have a right triangle. So first chapter always on trigonometry, we define some very basic terms, sine, cosine and tangent, which are there to relate sides of right triangle, right? So let us say this is our right triangle ABC. So the sides will be lowercase a, b and c. Now in this particular triangle, we define sine ratio, cos ratio with the term so cut over, right? So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent, right? So that is an easy way to remember. So you could write this as sine of, in this case, sine of A will be equal to the opposite side A over hypotenuse C. Cos of A will be equal to adjacent side B, right? So over C, and tan of A will be equal to the opposite side A over B. Now many times you use trigonometry when we are given points in coordinate plane. So in that case, how are the things related? Let's say we have a point P here. Let's say P is x and y. These coordinates x and y also help us to find the angle which the terminal arm makes with the initial arm, which is always assumed to be along x-axis. So let us say if this is theta. Now in this particular case, as shown here, if we have to define our trigonometric ratios in where the relations could be seen as, if x and y are the coordinate points, let me draw a line here to write down these formulas on the right side. Then from O, the distance OP, if I call this as R, will be equal to square root of x square plus y square. Simple Pythagorean theorem. Perfect. So if you drop a perpendicular from here, then this height will be y, and O2, let's say this point is Q, that distance OQ is going to be x, correct? So now we can write sine theta as equal to y over r, cosine theta as equal to x adjacent side over r, and tan theta as equal to y over x. Now here you also see one more very important thing, and that is how we link trigonometry with linear system. Tan theta is y over x, the ratio. So we also see that tan theta is equal to slope of the line. Right? So this is very important to understand. Now from these relations, we can easily see that tan A, which is A over C, could also be written as, if I divide both by C in this case, okay, so we have A over B as tan theta. If I divide by C, the hypotenuse, it becomes A over C over B over C. That means I could write tan A as sine A over cos A. So that is one of our first identities. Perfect. So tan A is equal to sine A over cos A, since A over C is sine A and B over C is cos A. You get it. Correct? Now let me derive the formulas for Pythagorean identities right from here. Right? So we'll do it on this side. Trig identities. Very simple, straightforward derivation. We can apply the Pythagorean theorem. So r square here is equal to x square plus y square. Now if I divide this by r square, then what happens? R square over r square is 1. X over r is cos theta. So we get cos square theta. And this is sine square theta. So we get our trigonometric identity 1 equals to cos square theta plus sine square theta. Perfect. Now if I divide this by, let us say, cos square theta, right? So we have this identity here. We could do something like this. We have r square equals to x square plus y square. We could divide everything by x square, for example. In that case, what do we get? R over x is reciprocal of cos, which is secant, right? So we get secant square theta equals to x over x is 1, y over x is tan. We get tan square theta, right? So you see, the Pythagorean trigonometric identities could be written like this. Now that reminds me of our reciprocal ratios, right? So let me rewrite here. What are reciprocal ratios? We also call them reciprocal identities. Okay. 1 over sine theta is defined as cosecant theta. So we can say cosecant theta is 1 over sine theta. Secant theta is 1 over cos theta. And cotangent theta, written in short as cot, is 1 over tan theta. So these are our reciprocal identities. So when we are writing the Pythagorean identities, you will see many of these reciprocal identities. Perfect. Now there's one more formula here, which I will write, and I'll rather extend on this side, so that I could write these formulas in different fashion. Now, if I divide instead of x by y square, right, we have got r over y square. In that case, we will get r over y is reciprocal of sine, which is cosecant. So we get cosecant square theta equals to x over y is cotangent, so cot square theta plus 1. So that is the third identity which we are going to get. So these three are our trigonometric identities in Pythagorean form. Now these are very important identities and they can be used in many different ways. For example, let's work on 1 equals to cos square theta plus sine square theta. Now in this particular case, I could always write what is cos square theta equals to. We can say cos square theta is 1 minus sine square theta, correct? Now you could also write this as 1 plus sine theta times 1 minus sine theta. Do you see that? So that is how we can work with these identities. Similarly, sine square theta could also be written as 1 plus cos theta times 1 minus cos theta. Do you see that part? Correct? So we could play with this and create many more identities. So what you could do here is that work with these identities and see how many different formulas we can actually get while working with these identities. Let me play around with this identity, right? So see how we can play around with it. If I take cot square theta to the left side, I get cosecant square theta minus cot square theta equals to 1. Now this is difference of squares, correct? So I could always write this as cosecant theta plus cot theta times cosecant theta minus cot theta equals to 1. Do you see that part? So we can always use this particular formula to really get many more related formulas from what we have. Perfect. Now, I'm leaving this space to give you three very important formulas. If you look at this triangle, then the angle A and B are also related, right? So you can see that angle B is basically equal to 90 degrees minus angle A. Now that helps to give us few more identities which are extremely important. So let me write these identities like this. If I have cos of 90 degrees minus A, what is this equal to? Now when I say cos of 90 minus A, I'm actually looking at this triangle from the angle B, right? So that is cos of B, right? Cos of B will be A over C, which is same as sine of A, right? So cos 90 minus A could be written as cos of B and can also be written as sine of A. Now this is very important to understand. So that is how we can actually at times relate the 90 minus A type of angles. Perfect. So we'll take this cofunction identities, these are called cofunction identities, and place them right here at the end of this particular formula sheet for us, right? So now I'm writing for you cofunction identities. We can write sine of 90 minus A, so this is all degrees, is equals to cos A, right? Tan of 90 minus A is equal to cotangent A, right? And cos of 90 minus A, we have already given you as sine A. Do you see that part, right? So, cofunction, perfect. So, the cofunction for sine is cosine, for tan is cotangent, and for cos it is sine. So in any triangle, if you have 90 minus A situation, you could relate it with the cofunction identity as shown here. So this page gives us a lot of information about the formulas, the basic formulas which you can use to solve any right triangle. So in any right triangle, that is how you could solve. And these are the identities which you will use. Perfect. Last and not the least, normally for finding the ratio, we use sine of A. But what is A equals to? A, the angle A, you used to have sine inverse. So sine inverse of the ratio A over C. So inverse function is used to find the angle. So if you want to find the angle, then you need to find the angle using the inverse key on your calculator, right? So sine of any angle will be a ratio. It does not have a unit. And remember, since these two sides are smaller than the hypotenuse, sine A will always be between 0 to 1, the absolute value of sine A, correct? So let's talk about this and other identities in the next page. Let us see the formulas which you could use for any triangle, right? So here is any general triangle, not necessarily a right triangle. So in such triangles, we could solve using sine law and cosine law. So let us say this triangle has sides A, B, and C. We use sine law or cosine law to solve these triangles. Sine law can be written as sine A over A equals to sine B over B equals to sine C over C, right? Now it could be written the other way also. For example, you could also write this as A over sine A, B over sine B equals to C over sine C, correct? It is important to note that a triangle can be solved using sine law if we are given what? we need a combination of side and opposite angle. That is kind of critical, right? So it could be a side with two angles. That should work because you can find the third angle, correct? Or it could be side, and the third angle, right? So if I give you these two sides and the third angle, it can work. So it can work with two sides and an angle, but where the angle is not included angle, right? It is some other angle, not the included angle. This is very, very important to understand, correct? Now, also it could have been like ASA, two angles, side in between. So in such cases, you use sine law. But if you have, for example, three sides given to you, then you use cosine law, right? So in that case, we use cosine law. So cosine law will be used if you have three sides or you have a side, angle, side situation. So in that case, if you have three sides, you may have to find an angle. If you have two sides and an angle, then the other side. So let's write down those formulas. So one is a square equals to b square plus c square minus 2bc cos a. That is how you can find the missing side. And if you want to find the angle, it has to be rearranged, right? So you could say cos a equals to b square plus c square minus a square divided by 2bc. Perfect. That is how it is. So remember this part. If you want to find, let's say, side b, the angle will be b. Only change, right? So the numbers will change, all these letters accordingly, correct? So that is how you could actually use cosine law to find solution of a triangle. Right? So you should be given three things. Either three sides or side, angle, side. Okay. Now you'll also notice that many times we are not just working with 0 to 90 degrees. In a coordinate plane, we need to look into all the angles. So in quadrant 1, we have seen that all are positive. In quadrant 2, sine is positive, 3 tan is positive, and C, the cosine is positive in quadrant 4. So these are our quadrants, right? Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Now based on these quadrants, we have many more formulas, right? So one of them, for example, will be sine of 180 degrees minus theta is equal to what? So when I say 180 degrees minus theta, we're actually looking into what kind of setting? Well, let me draw it here. Small one, right? So I'll just draw a small one here. So we're looking for something like this. We are always comparing with something in the quadrant 1 with 180 minus theta. That is 180 minus theta situation. Now, sine is positive in quadrant 2. 180 minus theta means you are in quadrant 2. So only sine remains positive, so it becomes sine of theta. However, cos of 180 degrees minus theta will become negative cos theta. Similarly, tan of 180 degrees minus theta will become negative tan theta. Well, if you have plus here, then things will change, right? You are in quadrant 3. Tan will become positive. So let me write down here. If we have sine of 180 degrees plus theta, then in quadrant 3, now the situation changes, right? Now with this set, we are looking into triangles which are in quadrant 1 and quadrant 3. So only tan will be positive, right? Sine will be negative. Perfect. Cos of 180 plus theta will be minus cos theta. However, tan will be positive, right? Right. Now we could also have relations with pi by 2 plus theta, right? So in that case, the scenario is kind of like this. So let me write down here to save some space. So we have sine of 90 degrees plus theta. That means we're looking into a situation where we have triangle kind of like this. This triangle tilts like this. So sine becomes cosine, cos becomes sine, correct? So in this case scenario, things are slightly different. Sine 90 plus theta, sine is positive, becomes cos theta. So these are cofunction identities, right? Cos of 90 plus theta, cos is negative, so it becomes negative sine theta, and tan of 90 plus theta will be equal to, tan is also negative here, so minus cotangent theta. We can extend these formulas and write so many more, but I'll just now take the last example related to this series, which will be 270 plus theta, so that we talk about quadrant 4 now. So we could have situation where the point is in quadrant 4, and we could have 270 degrees plus theta. Now in quadrant 4, sine is negative, so we'll have minus cos theta as equivalent ratio. For cos of 270 degrees plus theta, in quadrant 4 cos is positive. Therefore, it will be positive sine theta. However, tan of 270 degrees plus theta will remain negative. So it will be minus cotangent theta. So the function, cofunction is related when we are talking about pi by 2 plus theta, 90 plus theta, or 270 plus theta. Is that clear to you? Correct? So these are very important formulas which we should be considering and we should remember while working in trigonometry, right? Now, we'll also talk about the graph of these trigonometric functions. So sine wave, as you can see, is kind of like this. So that is the sine wave. What you always notice here that the wave is between plus and minus 1, correct? And this is from 0 to 2 pi. I've only shown you one wave, so 360 degrees. We are talking about angles in degrees at moment, right? So that is our sine wave. Let's say sine theta, and this is angle theta in degrees. Cosine theta, on the other hand, is a wave which starts with the maximum, correct? And then it ends with the maximum at 360, correct? It continues. These things continue. They are periodic waves, right? So in the formula sheet, you can actually make these waves 90 degrees, 180 degrees. They help you to find the value for different angles, correct? And this is 360 degrees. From 1 to minus 1. As you can see, the value of sine and cosine is always between plus and minus 1, correct? So it cannot be more than 1, since in the ratio you have hypotenuse in the denominator. Kind of very important to understand, correct? For the tan ratio, what we normally do is show the waves. Let me write down here tan theta as a ratio of sine over cosine. So when you divide 0 by anything, you do get 0. However, if you divide by 0, you get a vertical asymptote, since you cannot divide by 0. Is it okay? So all these zeros will translate to vertical asymptote. So if I extend this like this, we have a vertical asymptote here also for tan theta, correct? So the tan theta graph is kind of like this. It goes from minus infinity to plus infinity. You're getting my point, right? So whenever, I'm sorry, this was the asymptote. So this portion is not correct. Okay, so the zero will be at 180 degrees. They are not kind of related. So 90 degrees, this is, let me write like this. Okay, let's write this as 90, right? That is better. And let me write this as 180. It's okay. That's fine. Let me show it like this, right? So we'll kind of extend it since, okay. And this will be, so the 0 is at whenever sine is 0. So sine is 0 at 0, so we have a 0. Sine is 0 at 180, we have a 0, right? And then at 360, we'll have a 0, correct? So this wave is going like an asymptote, and that point is 270. Now we have the half wave. So that is, let me go like this, correct? So this point here is 360. Do you see that? So for a tan theta, we'll have 3 zeros, just as we have 3 zeros for sine theta. Perfect? So these are my 3 zeros. Perfect. Okay. Now at times, you may also do modeling. So in that case, we have to use the formula. We can write any value y as amplitude times sine of k times t minus p plus q, correct? So that is modeling. So in any model with sine or cosine, you could have this kind of a situation, correct? In this kind of a situation, time period t and k are related. K is related with time period t, right? So you could write time period t as equal to 360 degrees divided by k, or k is equal to 360 degrees divided by time. So that is how you get k, which is horizontal compression. Q, the axis, can be written as the average value. So it is maximum plus minimum divided by 2. Amplitude A is always positive, and it is equal to difference of maximum and minimum divided by 2. So that helps you to write equation of any sine function from the given graph, right? So that is how you could actually model a sine wave or a cosine wave, correct? So I hope these things help you to get all the formulas in one place. Now in the next page, we'll talk about the formulas related with sine of a plus b plus or minus b, cosine of a plus minus b, double angle and half angle. So in part 2, we'll discuss, rather also show you a few derivations of all the formulas related with sine a plus b minus b, cos a plus b minus b, tan a plus b minus b, double and half angle formulas, right? So I hope you find it interesting and useful. So half of the trigonometry, which you do in up to grade 11, is based on these formulas, right? So the rest half, which you do from grade 11 to 12, we use a plus b compound angle formulas, which I am going to discuss with you in part 2. Hope that helps. Feel free to write your comments and share your views. If you really like and subscribe to my videos, that'd be great. Thanks for watching and all the best.